Okay, last video you were asked to try a torque ladder question where you were told the mass of the ladder, which was uniform, was 10 kilograms, so your FG of the ladder would be here. The full length of the ladder was 10 meters. The person was only a third of the way up, so they're going to be here, FG of the person. The angle down here was 60 degrees. We have an F normal of the house up here. There's no friction at the top. We have an F normal of the ground at the bottom and F friction of the ground. And we're told the friction at the bottom, the coefficient, was 0.2. And it wanted you to find the mass of the person. So you could start with the sum of the forces in the y direction. And it's going to be 0. So it'll be Fn of the ground minus Fg of the person minus Fg of the ladder equals 0. Always solving for the normal in the y direction. So m of the ladder g plus m of the person g when you take it over. You can't get a number for this because you don't know the mass of the person. If you do the sum of the forces in the x direction, also 0. There's going to be F normal of the house minus the friction on the ground equal to 0. So F normal of the house will equal the friction of the ground, which we know equals mu normal of the ground. So we end up getting F normal of the house to equal mu brackets mg of m of the ladder g plus m of the person g. We can't find a value for this, but we'll be able to fill in our torque. So we go to sum of the torques. Should be equal to 0. So a torque from the normal of the ground, a torque from the friction on the ground, a torque from the normal of the house, a torque from the ladder, and a torque from the person should give us 0. Assuming we're going to pick our pivot point here, these first two go to 0 because their r's will be 0. If we pick our pivot point there, the normal of the house will be positive. The ladder and the person's torque will both be negative. So you'll have R normal of the house, sorry, my papers, F normal of the house, sine theta, normal of the house, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the person, FG of the person running out of room, sine theta of the person equals 0. I'm just going to move it here. So we'll have R normal of the house, and instead of F normal of the house, we're going to put in this mu m of the ladder g plus m of the person g. Okay, and then close this bracket, sine theta normal of the house, minus R of the ladder, m of the ladder g, sine theta of the ladder, minus R of the person, m of the person g, sine theta of the person equals 0. So you're going to multiply through here, R normal of the house, mu m of the ladder g, sine theta normal of the house, and then the second term will be R normal of the house, mu m of the person g, sine theta normal of the house. And then the other two terms stay the same, R of the ladder, m of the ladder g, sine theta of the ladder, R of the person, m of the person g, sine theta of the person. Okay, there is a g in every term, so cancel it. You're solving for m of the person, so keep the two terms with m of the person on this side, and we can pull it out. So it'll be R normal of the house, mu, g is gone, we factored out the m sine theta normal of the house from this first term. And from this term that we're keeping, R of the person, g is gone, we factored out the m, so we're keeping this term, sine theta of the person. Close the brackets, the other two terms go to the other side, R of the ladder, m of the ladder, sine theta of the ladder, minus R normal of the house, mu m of the ladder, sine theta normal of the house. Divide by your bracket. So m of the person will equal r of the ladder, m of the ladder, sine theta of the ladder, minus r normal of the house, mu m of the ladder, sine theta normal of the house, divided by your bracket, r normal of the house, mu sine theta normal of the house, minus r of the person, sine theta of the person. Fill in your numbers. R of the ladder, it was a 10-meter long uniform ladder, so R should be 5. The mass of the ladder was also 10 kilograms, and the angle at the base of the ladder was 60, so the angle for the ladder itself will be 30. R normal of the house, 10 meters. Mu was given to us to be 0.2. Mass of the ladder, 10 kilograms. Angle at the top, 60. Divided by R normal of the house, 10 meters. Mu, 0.2. Angle for normal of the house, 60. Minus R of the person was 1/3 of 10. So 1/3 of 10 meters, 3.3 repeating. Sine of the person, 30. Okay, and I don't think I lost any negatives. So when you do this, you should get a mass of the person to be 117.45 kilograms. Okay? And that's about as tough as the torque ladder questions will be, because I won't give you the friction at the top. Okay, so that's one that I asked you to do for homework. And the other two that I really wanted you to do homework were on page 529. Okay, so the first one, oops, be good if I had that on the paper, wouldn't it? The first one is number 27. And you have these buddies who are climbing mountains, and they just happen to have this handy dandy ladder with them, which they put across this huge crevice. And it says the crevice in total is 4.1 meters across. And it says the mass of their ladder is 3.6 kilograms. And the first, and it's uniform. So it means halfway in the middle will be the FG of the ladder. It says the first person starts to climb across the crevice and reaches a point 1.8 meters from the edge. So they're about here. This is FG of the person. Okay, and that person and her gear is 87 kilograms. And it wants to know what is the force on the ice on each side. So the ice is going to be pushing up here. It's like a normal force. And it's going to be pushing over here on this side with a normal force. Now, if the person was slap dab in the middle, the two forces would be equal, but they aren't. They're off to one side. Okay, and really I'd have to say 4.1 meters, it's a huge distance for a 3.6 kilogram ladder to be spanning it. And look at the depth of that crevice. Who in their right mind would do this? Just wanted to point that out. All right, so if you pick your pivot point here, because really we have two unknowns, N1 and N2. So if you pick your pivot point here, it gets rid of one of the unknowns, and then do the sum of the torques. So sum of the torques will equal 0, and it'll be torque from Fn1, torque from Fn2, torque from the weight of the ladder, and torque from the weight of the person. If we pick our pivot point there, Fn2 will be positive, and this one will go to 0. This will be positive, negative, negative. So it'll be R of the normal, F of the normal number 2, sine theta of the normal 2, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the person, FG of the person, sine theta of the person. If you look, all the angles are 90. So all of these are going to go to 1. And we're looking for Fn2. So take the others over, R of the ladder, M of the ladder, G, plus R of the person, M of the person, G, divided by R Fn2. So Fn2 is equal to R of the ladder. It was a 4.1 uniform ladder, so 2.05 meters. It was a 3.6 kilogram ladder.